Hey folks, okay, well we want to get into a little bit of input and output here. A program isn't much good if it can't get information from the user and it can't display things to the user. So there's two different approaches. One using the kind of traditional C++ approach using routines called cin and cout. We'll cover those in the next video. For this one, I want to use kind of an older C-style approach using routines called printf and scanf. And again, primarily because these are more similar to what you're going to see in other languages. Again, I want you to be exposed to both approaches, and I'll let you pick which ones you actually want to use for labs and for the project. And we'll do some basic testing on each in the quizzes, but you should see both. So today we'll do printf and scanf and see where we get to. All right, so we want to be able to display things on the screen, and that's what we'll use printf for. And we want to be able to read things the user types in, and that's what we're going to use scanf for. I guess the input-output with printf scanf is a little misleading here. The input is scanf, the output is printf. All right, so these are both in the cstdio library, which I think we've used a couple of times in the examples so far. And in the first lab, we looked at just the basic use of printf for string literals. If I've just got a bunch of text I want to print on the screen. So we'll recap that quickly. And then I think in our last lecture, we just barely got into the use of embedding values into these strings when they're displayed. And so we'll get a look at some of the common types of data that we can embed in these strings when they're displayed on the screen. And these will use some special formatting characters that we'll talk about. Now, we can get into some fancier formatting options. So, we can control things like how many decimal points it displays after or how many digits it displays after the decimal point in a displaying a float, or we can get it to pad to certain widths when we're displaying things. So we'll look at some of those. And then we'll switch over to looking at input with scanf. And we'll look at just the basic process for reading something the user types and storing it in a variable. Then we'll get into some of the nuts and bolts on how Whitespace, things like tabs and spaces and new lines, interact with the way scanf works. Then we'll take it a step further and look at how we can get scanf to read things from the user when we expect a certain format. We expect the user to enter things in a certain way. So we'll talk about that, and then we'll just briefly touch on extra information that can be returned by printf and scanf. So this is more or less where we want to go. Again, we'll take a look at some examples as we play with this. So we mentioned just basic printf for text output. If I just have a bunch of text that I want to display on the screen, we just hash include our cstdio library, and then it's printf, and in the double quotes, in the brackets for printf, whatever text we want to appear on the screen. Now again, everything that, if we have 12 different printfs in a row, all of the output is going to appear kind of tacked one on the end of the other as the program actually runs. So if we want things like new lines or tabs or other special characters to get embedded in between, we have to actually put those in one of the printfs at the spot where we want it to be. So if we want to print this is output and then have it go to the start of a new line, we would put a special character at the end of that indicating put a new line here. So a couple of the most common special characters we'll use are the \n to indicate a new line, and the \t to indicate a tab. There's a whole bunch of others, \g for bell, \f for a form feed, \r for a carriage return, lots and lots of others. But those are the ones we'll start with. So just as again, kind of a quickie recap as to what this looks like. So if we were to create a simple output program, we'll hash include our IO stream. Oops, I should actually spell that all lowercase. Or pardon me, hash include our C standard IO. And we'll have our int main. and we'll just put in a bunch of printfs here. Printf, blah, blah, blah. And then a printf and more stuff. And then a printf. Maybe we'll throw in, maybe we throw in one of those tabs and maybe a space and some dot dot dots and some more spaces and maybe a new line after that. Why not? So we try something like this, and again what's going to happen is it's going to print that blah blah blah, and then the next instruction is going to pick up where that left off and print the and more stuff, and then that's going to pick up where that left off and print a tab and a space dot 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 dot, and then a new line. And so hopefully if we compile this, so I'm going to turn my warnings on, dash wall and dash wextra, and my simple output.cpp, and I'm going to just call this simpx for my executable. Oh, wow. No apparent errors, so let's try running simpx. And again, we got our blah blah blah, then immediately after that it printed the and more stuff, and there's a tab in there, and then the dot dot dots, and then it went to the start of a new line. So again, you can just throw as many of these printfs as you like, and hopefully get, eventually tweaking things to get the output that you want. All right. Now, after that, we got into the idea of trying to embed a variable value into the midst of something like this. So the notion was that we put a special set of characters into that text string indicating that a value is going to go here. And those special characters began with a %, and then they'd have something that said, is this going to be an integer, is this going to be a float, is this going to be a character? And there were specific characters for that. So a %d represents an integer in base 10, %f represents a floating point, %c for a char. There's other types of ints, so there's longs, so %ld for a long. There's bigger floats called doubles, so there's a %lf for those. If you can embed a text string inside another text string, so you can do a %s for those. So there's a variety of different format characters, and we'll get into the fancier issues of formatting in a bit. But again, just as an example, you can go through, create some variables, and then to embed them in the string, you put the % whatever, and again, you're going to specify what kind of data is going here. So x is an integer, so I want an integer value to go here, so I use a %d. And then after your string, you throw in a comma and the thing you want embedded there. So again, when this is compiled and run, the x will appear where the %d is. So this will come out as some integer and then the value of x, I guess some integer 3 here, and then a new line. Or some float 1.5 and then a new line. So again, let's just do a quick play with that and make sure we've got kind of the hang of it. So let's say, I'm just going to use ints for the time being, so let's say we create an integer x with value 10 and integer y with value 23, and then let's change this string to say something like x is, and we'll throw x in here, and y is, and we'll throw y in here. So again, you can have as many of these things as you like in a string. No, let's just leave it like that. We just have to make sure that after the string is over, we give the values that are supposed to go in there. So I want an x to go in first, and I want a y to go in the second one. So we put in our commas and our variables, and hopefully it compiles okay, yay! And we try printing it out. And sure enough, we get the x is 10, y is 23. You'll notice that that gets a little bit difficult to read because we haven't put any kind of white space or any kind of separation in between the value of y and whatever's coming next. So it wouldn't be that unusual for us to go through and say, well, Maybe I'll try and make this look a little bit more readable, and I'll throw a new line in after that value for y. And compile it and try it out. And that's a little bit more readable. But again, you can go through this process and it works for any of the different data types. There are a ton of different formatting characters available. We'll get into more of them as we plow our way through here. All right. So we can embed data values in our printf now. So now let's take it one step further and say, can we format the what's appearing there? So we can embed an integer value between the % and the D or the F or the C or whatever it is. And this basically says, whatever's supposed to go in this spot, I want padded out to a certain minimum width in characters. So if I say %5D, for instance, this is going to say if it takes fewer than 5 characters to print the value of X, then put extra spaces beforehand to pad it out to 5 characters. If X already takes up 5 or more spaces, it just ignores the format character. But this way we can start getting things padded out to specific sizes if we want. So let's go back and take a look at where that might actually be useful. So let's try our same old example here. Let's make X just a 1 here, and let's make Y 230. And so what I'm going to do is I'm going to print X and Y underneath each other. So we'll have X once and we'll have Y once. And I'm going to get rid of this and more stuff. Actually, let's get rid of this as well since we're not really interested in it. So we've got 2 different sizes of value being printed out, right? The 1 just takes a single character to print out. The 230 takes 3 characters. So I'm going to try padding each of these things to 5 characters wide and see what we get. Oh, let's throw in one more. Let's throw in a Z that's I don't know, 1 2 3 4 5 6. So something that's actually bigger than that. And we'll print out Z as well. And we'll pad it to 5 characters, just to show that it ignores the padding when it's something that's already that big. So we'll try compiling the beastie, and we'll try running it. And so you can see that it's actually padding that 1 out with extra spaces to make it take up 5 characters, and it's padding Y out to that same amount. So one of the places this comes out is when you're trying to print things in columns, so to speak, where you want things to line up one under another, and you can use this kind of padding to do that. So, and again, you can see in the last case, the padding wasn't any use because the thing we were trying to print out was already bigger than the 5 characters we specified. So we can get into a little bit of simple formatting there. We can do even more if we're trying to print out floating point values. So for floating point values, we can specify how wide it's supposed to be overall, including the decimal point, and we can also specify how many digits exactly we want to appear after the decimal point. So 6.2 means we're going to have two digits after the decimal point, and we want to pad to a minimum width of 6 overall. So if we give this a try, so this time let's make them floats. And so we're going to use F's in here. And let's make X 1.0 and make Y 0.23001. and make Z, and I don't know, 123.456. And for each of these, we'll just print them out using this 6.2, for instance. So 6 characters overall, including the decimal point and 2 digits after the decimal point. And we'll try compiling, and we'll see how this turns out. So you can see we got the 1 printed out with, cut off after exactly 2 zeros. The 0.23 again cut off after 2 digits after the decimal place. The 123.456, it actually rounded here. So this was printing out the 456, cut off the 6, rounded it. And you can see that threw extra spacing in the cases where the output was shorter than the 6 total characters. And you can see here it gave us 6 total characters, right? The 1, the 2, the 3, the decimal point, the 4, and that last 5 rounded up. All right. So we can play with a little bit fancier formatting with our printf and floating point values. Okay, I think that was most of what I wanted to get into for the basic of output for now. So we'll take a look at the basics of input, getting values from the user. And this is done using a routine called scanf, also in that cstdio library. So it reads from standard input, which is generally what the user is typing. And again, it uses one of these format strings to specify what kind of thing it's expecting to read in. So again, a %d for an integer, a %f for a float, a %s for text, a %c for a character, that kind of idea. The only thing that's a little different about it is that we're going to put a special character before the variable that we're trying to read a value into. So we want to read something the user types in and put it in a specific variable. And so the syntax looks like in a string, we put the kind of data we're supposed to be reading in. So in this case, we're expecting to read an integer. And in this case, I want to put it into variable x. So I throw this and symbol and the x. Sorry, I'm going to keep referring to this as and symbols because we use it for logical and in the as part of the language. So I'll actually technically bitwise and, but I am just I'm not going to be able to break that habit. I am going to keep referring to this as the and sign. Let's see. So again, scanf reads the data, puts it in the variable. And again, just like with printf, it reads sequentially from everything that's been typed in. So the first scanf reads, the first bunch of characters that the user typed, and then the next scanf picks up reading what the user typed from that point on. So think of it kind of like reading through a book where it's just taking the characters in sequence. Now, one of the things that scanf assumes is that we've got kind of white space separating all the different values. And one of the things that scanf will do is skip over any leading white space, any spaces, any new lines, until it actually starts seeing some data. And that's the point where it starts reading things in and trying to put it in the variable. So we'll play with that as we go. It doesn't read from the keyboard kind of the instant you hit characters. It's not until you hit enter that the data you've typed is available for scanf to read. So you have to type stuff in and remember to hit enter before scanf can actually see it. So if we have again a quick play with this. So now let's try maybe a little input.cpp program here. So let's again use our cstdio, our int main. I want to, let's tell the user what we're going to expect them to enter. So I'll do a printf that says, please enter an integer. I'm going to create a variable to store it in. So, I don't know, user input. And then I'm going to use a scanf, and I'm going to get it to read in an integer, so the %d, because we're expecting to read in an int, and then that and symbol, and the x, or pardon me, user input, the place where we want to store the value once we get it. And then we'll print it out just to see if we actually got it right. You entered, and again, a %d, and the thing they typed in. So let's give that a try. We'll do our G++ with our warnings. Input.cpp-o. Hey. So we'll try running that. And we'll see it go through this sequence where it prints the prompt and then waits for me to type something. Oops, dash, it should spell the name of the executable right. So it's asking me to enter an integer, and it's just going to sit there and wait, right? That scanf is waiting for me to put something in. So I type in, 123, and it's still sitting there waiting because I haven't hit enter yet. And so eventually I hit enter, and it reads it in and tells me, yes, you entered 123. Again, if you want an example of how this kind of skips over whitespace, so it says, please enter an integer. I'm going to hit a whole bunch of spaces, maybe a tab, maybe a couple of new lines, some more spaces, and it hasn't actually tried reading anything in as an integer yet. So now I try my 250 or something, and a bunch more spaces, and it's still sitting waiting for me to hit enter. Eventually I hit enter, and it grabs the value and says, okay, you entered 250. So you do have to be aware that it's going to skip whitespace that the user types in, and eventually it's going to wait for you to type in something and hit enter. Now, there are a few things to worry about if the user starts entering invalid input, but we haven't got a lot of ability to do error checking yet, so we'll gradually introduce that in the next week or two. However, let's pop back to our slides for a second. So again, this is kind of repeating that idea that it skips any leading white space. And the way it'll work is as long as, once it gets past the white space, it'll keep reading characters into the variable as long as they're valid for the data type that you're expecting. It stops when kind of either it hits more white space or it stops seeing things that are valid for what it's trying to read. So if I do something like int I and do a scanf into I, it's going to skip any white space, read digits into I, and stop when it sees something that isn't a digit. So if we go back to our previous example there, so I run my program and I enter something like 651, I don't know, G. It reads the 651 and it sees the G and goes, oh, that couldn't be part of the integer. And so it stops there and treats 651 as the integer. And the G is still sitting in standard input waiting to be read. Now that basically gets discarded when the program ends. But let's say let's modify our program a little bit here. Let's get it, after it tells us what the integer was, let's get it to try and read a single character. Oops, I guess I should create a character variable for it to read into. Char more input. So we'll get it to try and read a single character and put that into more input and print out that afterwards. The next char was %c, and we'll print out the extra input here. So now we're going to read an integer and a single character. So we'll recompile, and we'll try running it. And so this time, if I type in, say, my 650, and we'll just leave it at that for the moment, then in this case, it's going through and saying, you entered 650, you got that right. And the next char is, and so what's actually happening here is when I typed in 650 and hit a new line, it's reading that new line as that next char and displaying that. If I try my 650G again, 650G, it read the 650 as the int, and then after that, it kept on reading and grabbed the G as the next character in line. So again, scanf just keeps going sequentially through all of the things typed, grabbing data and putting it in, the next appropriate place. Let's see. Now, let's try something a little different here. So let's run that, and instead of typing an integer at all, let's type in, I don't know, garbage. So I didn't enter an integer at all. So in this case, again, when it tried to read the integer, it couldn't find anything. So it just gave me kind of the default value for that particular variable. It couldn't put anything into the variable. And then it picked up, the next scanf picked up where the old one left off, and since the old one kind of left off right at the beginning, that next character read, that next scanf, grabbed the G. So, sorry, I just realized that this is not appearing on the screen there. So we entered garbage. That first scanf couldn't read any of that into an integer, so it just left the integer alone, and then the next scanf picked up and grabbed the G at the beginning there. So it does take a little bit of getting used to the way scanf tends to behave. Now, we can get a little fancier still with scanf, and we can expect the user to enter a specific sequence of characters, before or after the other input that we're producing. So let's say I want the user to enter two numbers separated by a dash. Then I could set up my scanf to say I expect them to enter an integer, I expect them to then type in a dash specifically, and then another integer. And I'll read the first integer into X, I'll throw away the dash, and I'll read the second integer into Y. Right? So if you put extra characters, beyond just the %whatever, into your scanf string, then scanf thinks it's supposed to find those characters, read them, and throw them away. Right? So it's expecting the user input to have this exact form: integer, a dash, and an integer. And as with the other aspects of scanf, if it's expecting to see a specific character, as it's going through the sequence, and it doesn't see it, then it can't read anything at that point. It doesn't read anything for that. So you can get a little fancier. We're not going to play with this too much, at least not for the next little while. We'll just get the basics of scanf down, but it is something that you can play with a bit if you're interested. Okay, the last thing I wanted to mention for both printf and scanf is, in addition to actually printing out what you want, so in addition to having printf actually display things on the screen, or in addition to having scanf actually read something into a variable, they both actually give back a value that you can use. For instance, you can store it in another variable and you can do whatever you want with it. So in printf's case, it counts how many characters it actually prints on the screen when it runs. And it takes that count and it returns it as a value. So if I say, so I'm going to have something that keeps track of how many characters printf prints out. So I'm going to say char count is equal to whatever printf gives back to me. So printf is going to display a value on the screen, and it's going to give back a value that I'm going to store in char count. So if printf prints out, in this case it's going to print out x is 470 and then a new line. So the count of the number of characters would be, 1, 2, 3, 4, 5, right? It's counting all the spaces and things. 5 characters plus the 3 for 470 plus 1 for the new line. So it's a total of 9 characters get displayed on the screen. So char count is going to be 9 at the end of this. So again, you can, and as we get into sort of playing with fancier output control and fancier displays, there are times when it's useful to know how much you just displayed on the screen. So we can actually get that information from printf in addition to having it actually display things. And similarly, scanf gives you back a count of how many characters it just read in to during that last scanf. So if you do a scanf and you're storing it into an integer, if what the user entered was 12, scanf's going to return 2 and say, I just read 2 digits. You know, if they typed in 640, it's going to return 3, saying I just read 3 digits. So this is in addition to actually putting that 640 or whatever into the variable. So there's the one part where it's reading a value from the user and putting that into a variable for you, and the other part where it's returning a value that tells you how many characters it just read in. So these are going to be, in Scanf's case, this is going to be useful for error checking to see how many characters of data we read from the user, and we'll be able to check that and see if that actually seems valid. If it's way too small or way too big, then maybe something went wrong in what the user was typing for us. So there is a quickie introduction to printing output and reading input using printf and scanf. We're going to be using these a lot over the semester. Again, we'll come back to these when it comes time to look at error checking, and that's where we'll really start to use these return values. But for now, we've got the ability to print information, we've got the information to read information from the user, and we've got the ability to do computation. So actually, maybe this is a useful point to talk a little bit about things like the current lab, where you're trying to prompt the user to enter a value, you're trying to read it in, and you're trying to do computation with it. So maybe we'll take a quick example of, let's have a program that, so I'm just going to put a little description of my program up here at the beginning. Oops. This program prompts the user for 2 real numbers, reads them in, multiplies them together, and displays the result. So, again, I'm going to use my cstdio. I'll have my int main, and oops, better get my brackets right. So we'll prompt the user. Please enter 2 real numbers. I should probably declare a couple of variables to hold them. Num1, num2, and I'll read them in. Again, if I'm prompting them to enter real numbers, then they could very well enter 27.5, so I better make this a float, not an integer. And let's have another float for the result, or let's call it the product. Product. Oh, good grief. Can't type today. So we'll use scanfs to read those 2 values in. So we'll use a scanf %f for the first one. So we'll read the first one into num1, and then we'll do similarly for num2. And then we'll give them a message that tells them the product of, blah and blah is blah. So the product of %f and %f is %f. And we've got the 3 things to display here, right? Num1 and num2 and the product. So this is going to go through and say, if they entered 23 and 200, it's going to say the product of 23 and 200 is, and whatever. I guess it would help if I actually computed that, wouldn't it? So we want to say the product, oh good grief, the product is the result of num1 times num2. So we can go through and put together a program like this where we say, okay, well, we give them a prompt describing what we want. We make sure we've declared all our variables. We read in the information we want to get from the user. We do any computation we want, and we display the results. So let's try our compilation here, and again I'm going to turn on all of my different warnings so the compiler can give me hints as to anything silly I might be doing. I want to compile sampleprog.cpp, and I'm going to just call my executable samplex here. And oh hey, woohoo, no syntax errors. Let's try running this and see if it actually does what we want. So it asks me to enter two real numbers. So again, it skips over whitespace, so I can throw in a bunch of spaces. Eventually I say 5.4, and again I can enter a bunch of spaces. It's gonna read in one of them. It's waiting for me to, so remember it's got to read both before it starts doing the next printf. So what'll I do for the other one? Let's say 0.1 for the second one. And so it goes through and tells me, okay, the product of the first one, 5.4, so that's num1, and 0.1, num2, is 0.54, so we actually get kind of the results we want. Again, maybe we decide that we don't want all those trailing zeros, so let's go with an 8.2, let's go with 8.3 for our formatting. So 8 characters total with 3 digits after the decimal place. Oops. I don't want those in the scanf, I want those in the printf. So when I print it out, I want 8 characters in total for the output, 3 of which are digits after the decimal place. Compile again, run again, and let's try our 5.4 and 0.1. And there we go. So we can play with formatting. We can play with the kinds of results that we're going to get. Maybe one other thing that I'll mention with the printf is there's a format that tries to kind of auto-format for us for floats. And it's called %g, and so what it'll do is print the float out but drop any trailing zeros. So if let's try this one more time. So let's say I enter 125.714000, let's get a whole bunch of zeros here, and 12 point and a bunch of zeros. Then it's going to read in the two values, do the computation, print the result, but again, it prints only those digits that are necessary, right? So since 12 is basically an integer, it drops the point zeros, it drops the trailing zeros after the first value, it drops the trailing zeros after the result. So the %g is another formatting option that is sometimes a little cleaner. All right, that is where I will leave it, and we will pick things up. I think next time around, we'll take a look at the same sort of idea, but with cin and cout instead of the printf and scanf. All right, folks.